Data normalization. I think you know this concept already. So when we do the machine learning, we do data pre-processing before we start any training, the machine learning training. And the data normalization would be one of the most important stuff for data pre-processing. Are you explaining why? Okay, so let's say I have two attributes here, A and B. And my attribute A has the value range between 0 and 10, and B has a range between 0 and 1,000. Okay, there's a question. What do you think, guys? Which attributes are more important?
Can't say that. Which any feature could be useful. So we don't know which feature is more useful, A or B. It's just the different mathematical values.
Wow, Yash. Yeah, he gave nearly two good answers. Right, I agree with you, Yash. We can't say which one is more important, right? Like say, I'm predicting weather forecast, but then, oh, this attribute B was actually Google stock price. Then, well, it's not important at all, right? So we know this value mean nothing, probably for us at least, but unfortunately for machine learning algorithms, because they are dealing with the numbers, they will think, oh, attribute B will be more important because they have higher number. They put the higher number for us. I don't want that. I don't want to make any bias to machine learning. I say that's their job, their machine learning algorithms' job to figure out which attribute is more important. So the least we can do is just remove the bias by doing the normalization. So getting R in the same range. Is that fair?
Yeah, that makes sense.
Yeah, it's good, isn't it?
Yeah,
So
if you look at like equation of like, let's say, n-dimensional plane, and that's what we're trying to do with the simple regression, trying to find like x and y attribute to find a straight line that separates the data. Data is like one side or other side, and if you look at the equation of that is like, just let's say y equal to mx plus c. All we try to do is just like, we're trying to find the multi-dimensional plane, which basically segregates all these different points into different sides of the plane, so you can easily categorize them, but you don't know which variable would they be. Like, it's up to you, like what you're trying to predict. So if one of the values are really high and one of the values are really small, the equation that we would have, like a1 plus x1, a2 plus x2, a3 plus x3, would be dominated by the variables from the higher size. So it's good to bring all of them in the same range.
You're so smart, Yash. I like that.
You are smart. I'm just trying to follow.
Cool. It's good. Anyways, yeah, thanks a lot. Okay, so the solution about these issues we just addressed, and easy enough. Just rescale your data. Good stuff. So the most common techniques are, I say, Z normalization and the 0-1 normalization. So the Z normalization is, you have training data sets. So you just calculate the mean and the standard deviation, and then just rescale your data with the value you just got, the mean and the standard deviation. And there's caveats though. When you rescale them, you have to rescale them for your test data set as well. And then once your prediction is done, you have to rescale back. So back to the normal scale. That's the key for this data normalization. Set 0-1 normalization. So you start the training data set again and get the minimum and maximum value, and just rescale them again. And okay, so I don't know, it depends on the preference. People use this or that. I don't know. But for me, I prefer that normalization. The reason is simple. The min-max, well, you can call min-max here as well. Right. I have I told I have a great data set for training. So I found the minimum maximum. But then somehow my test data set had a known value, which is above this range. So like smaller than my minimum, smaller than my maximum. So at the end, I actually didn't get the 1 to 0 scale, which isn't bad. Like still it's close to the 1 to 0, but like, what's the point? Like, so it's all about the preference. Me, I think I rather I give a little bit of computation over the pre-processing, but I use the Z normalization. But some people will say, well, it's fine. I know my data set and I can still go with the min-max. Okay, that's fine. So I won't say which one is the best, just you pick. Another highlight here, normalization is important, very important in many other areas of machine learning and optimization. Just let you know. I'll move if there's no questions.
So it's like one of the steps in the pre-processing of data before you train your algorithm.
Yeah, yes, that is perfect. Actually, I just mentioned minutes ago, and actually it's pre-processing, but after you predict your data with the rescaled data sets, then you must bring that back to the normal scale. Okay, that's one thing. So although it's called pre-processing, we have to process after prediction as well. Okay, good.